So I'm Shivam, as you all know, the software developer at Atlogys, and today's agenda for this collection over here is we will have a discussion on MongoDB, means what's the use of MongoDB, what the technology is, and what's the basic of it. So we'll understand it one by one. So topics to be discussed, topics which we will be discussing is why NoSQL, types of NoSQL, MongoDB, introduction of it, and features, who is using it, platform supported by it, and MongoDB compared to other DB technologies, MongoDB versus document DB technologies, what is document DB technologies, mapping chart, and CRUD and indexes. So I guess this is just so why NoSQL means can anyone tell means what is better, if anyone knows what is NoSQL? Is NoSQL better or MySQL or just the SQL?
It depends upon the database, which type of a structure we are using.
Okay.
And if it is unstructured, then we can go for noSQL. And for indexing purpose, if it is a huge amount of data we are using, then noSQL is better as compared to relational database.
Yeah. So basically NoSQL is nothing against SQL, it is just that it gives more availability, means it gives more storage power, more availability to the users to store data. Okay, so NoSQL stands for not only SQL, it's non-relational databases, and NoSQL attempts to address dynamic, means nowadays the structure, as the internet is growing, the structures are not constant. Means we can't have the constraints. We will follow only this structure. We have LinkedIn APIs or we have Facebook APIs. They keep changing. They keep upgrading their versions. So we can't stick to it, and we can't always say that this would be the structure and we will have this schema. We'll have this specific schema and that will follow it all. So what we do is we can have MongoDB, we can have NoSQL, in which it makes sure whatever the data might be coming, it will store all of it, and it won't just lose the data which lose the new data which is being given. So NoSQL helps to overcome this dynamic problem for structured data, unstructured data, semi-structured data, or polymorphic data. And now earlier we used to have 18 to 20 months of development cycle. So first for that we were using waterfall model. So what waterfall model did was, first we were freezing all the requirements, then we were discussing the schema, and then we will start development. And once the development is over, then we will deliver the project. But now we are following the agile model. What agile model says is, you freeze the requirement, start developing it, show it to the client, again start developing it with the outputs, with the inputs from the clients, and then, so it's an agile model. You have to work with it, and then the requirements changes as the requirements are shown, as the things are shown, the requirements keep changing, which lead to unstructured data or some new additional features. So in that case, we can't have the constant or fixed schema, so we use NoSQL in it. And even nowadays you see, earlier it used to be like a person used to write code and used to commit it to the SVN in a month or in weeks. But nowadays you can see in organizations there's every 2 days sprint, every 2 days commit, or every day commit, or every 1 day, means there are 2 commits or so. So for these models, we can depend on the NoSQL model and the scalability. So earlier there's one constraint with the SQL databases is that the capacity of the data is fixed, means you cannot exceed over it. But in NoSQL, what we do is you can exceed to any data. You just need to increase the system capacity, and it would handle everything by itself. And in NoSQL, there is one thing sure, you will always have a system that would be available for all the queries given to you. Means every time the availability will be there. There would never be a case when all the systems are down. So this is the main feature of NoSQL. there are few types of NoSQL. Means NoSQL can be divided into further categories such as key value DB. So what key value DB is? As you all know, for SQL, we keep the data in rows, but in key value databases we keep the data in a specific value and a specific key for it, like like any specific primary key or something like that. And you can keep anything, string, integer, any blob or JSON in the value thing. And so what makes it fast is if you know what keys are to be fetched, what data you need, you can store it in that manner. And column family, what happens is you store all the data not in rows but in column, and you arrange those columns in a specific family. Means if you have data for rows, if you have a data for employees, and you know there are grades in employees. Means there is an employee for like band A, band B, band C. So you will store the data in columns, and you will means you will collect the data in a family, and that family would have like band A would all the data of band A would be in one family, and rest of it. Similar is for document DB. Document DB is like you will have data in key value pairs, and each key value pair would be in a document. Like you can see over here, it's like author, Shivam Singhal, organization, Atlogys Private Limited. So this is a document. It has key value pairs, but it will have multiple key value pairs in a document. Like some of you have worked on JSON, I guess. So in JSON, what we have key value pairs, and like we have in APIs and all. So some of the big players which have key value DB is Amazon, React, and for column family is Bigtable, HBase, and document DB is BaseX, MongoDB. And today we will be discussing on MongoDB. Okay, is it clear till now? So MongoDB is the word Mongo has been derived from humongous. Humongous means enormous, large, means huge, and we all know that MongoDB is document-based document database. It is an open source, and it works on cross platforms, and it is document-oriented document database, but it stores its data into JSON. As you all know, I guess, JSON. What does JSON stand for? So similar is JSON. It's the binary form of JSON. For this is the format which MongoDB use to store data. So and the main thing behind means MongoDB is it have a very powerful query language. Means as you all know, nowadays developers are moving towards JavaScript. So every query can be done as we have the JavaScript JSON object, and the similar is the query. And there are many SDKs for the platform. To use MongoDB, you can use it with many platforms. SDKs are available like for C, C#, C++, and other platforms. Features of MongoDB. It's rich in query language. It has what all features it has. It has indexing in it, storage engines. There are two types of storage engines: MMAVP, which is memory mapping, and other is White Tiger. There's a feature of replication. By the word replication, we store the data. We have the replicated. We have the multiple copies of data stored at different systems. You understand? Means if either of our system goes down, we'll have another copy which would be answering to our queries. And we have cap collection. This is the unique concept of MongoDB. In this, what happens is we fix the size of a collection. By the term collection, we mean tables. So we fix the size of the collections, and in that, what happens is whenever we push a data into it, every time we push a data, it will store into it in the form of FIFO. all the data types, all the functions, all the predefined functions in the JavaScript you can have on the console, on the bash, on the shell script of MongoDB. So, means MongoDB is used by many of the big players in the industry, in the IT industry, and it fits in all kind of industries. Like it fits in Facebook. Facebook is also using it. Facebook's one initiative, Parse, it was using it as a backend technology for storing database. Google is also using it. Tops and all, MTV is also using it. So there are many industries, and it supports every, means it can support in every, it can be used in every industry. Not only means just for logging it or something like that. So there are many platforms that MongoDB support. Means it works on Linux, all the versions, and now we usually use either Amazon for deploying or Ubuntu for development and Windows for development. So it supports all of them. And MongoDB is the best technology for document store. As you can see the highest, you can see all the technologies for databases, that is for RDBMS and for NoSQL, and Mongo is on the top of the NoSQL, comparing neck to neck, not neck to neck, but just comparing next to the relational databases. And it is at top in compared to all the document DB technologies. Other DB technologies are Couchbase, Amazon DynamoDB, CouchDB. That's it. So, as we all know, as we all have worked on SQL, I guess. So there's nothing much in the terms different. Means what we have over here is database, and in MongoDB we also have a database for that. The same ideology for that. And over here we have table. Over here we have collections. We name those tables as collections. Over here we have row. Over here we have documents. Documents we understand as row, and there is no, means the row is over here is fixed schema. We have all the fields fixed. We will only have those fields which are defined in the table by creation, or we can alter after that. But in this we don't need to define any of the fields, or we can have new fields or some less fields while we are pushing the data. Means we can have the exact JSON being pushed into it, and that JSON being stored onto the files as JSON. All the columns over here, all the columns are named, all the rows column are named as column in the SQL, but in MongoDB it is named as field. Indexes are the same, and table joins are over here referred as linked documents or embedded documents. So the use of SQL was to the main feature of SQL was to normalize the things. Like we can break the tables down to keep the small chunks of data, but in NoSQL and MongoDB provides the storage limit. There is no storage limit. You can store any amount of data. So why to normalize it? We will denormalize it and we will keep all the data in one chunk. So for example, if you have a user page. So earlier what we used to do was we keep the countries in a different table, user countries into a different table, user profiles into a different table, experiences into a different table, and we have a separate table for each of them. But what we can do in MongoDB is we can keep all the data of a user into one document. What we can do is we can have a document which will contain the name, which will contain the contact details, which will contain its user experiences, what all places he have worked on, all the jobs, all the educational background, all other family background if we want, or every of its detail into one collection, and we can use that collection only. We don't need to keep join table, other relational things in other collections. Here also we need to specify a primary key, which would be a unique or one single primary key or a unique combination of multiple keys. Over here there's a primary key which is auto-generated.
I have one question.
Yep.
So when you said there is no joins concept, and we are storing like countries and everything in single table. So if I need to show the list of countries, so I need to create over all of the
No. You can have a master table in that. For that, what we do in SQL is we have a master table of all the countries, all the states, and all the cities. Over here, and what we do was for user, a specific user, we were having a relational table like user ID of this table and country ID of this table. So in this case, what we do is we have the JSON, we have country details, and in that we have an embedded document, and we keep the country's data in that specific JSON only. You understand? Okay. So let me show you. So now you understand what we do is we'll keep the data in this format. And earlier in SQL we used to keep like we'll have the table users. It will have ID, name. We have a country master table. We have ID name. We have user countries. It will have user ID and country ID. So this is the normalized form, but over here we can have the whole document in one place, and this would means enable us to read the data fast. Over here, when we will be requesting the data of a user, then it would be having a join for on users. It would be query and it would have left join over here and then over here. You understand? And over here you will have one single read operation and it would give all the data.
Okay. My question was to, I mean, when I'm showing the list of countries.
Yeah, in that case,
We have a separate collection.
we have a separate collection for that. Like,
But we are storing the countries there.
To overcome join operation, that's why we are keeping ID and name for a
There
user.
is data redundancy in
That I will say.
yeah, but it would means
It's much
speed up the things. Because data redundancy was reduced in SQL just because there was a limit of capacity. Over here we don't have the limit of capacity, and it is very fast in that terms. So we don't worry about the redundancy. If we need to worry about the redundancy, then we need to switch on the SQL. So so the question which I put on the first just in the starting of the discussion was which one is better. So he was somewhat correct and almost correct. I would say that it solely depends on what type of architecture we need, what type of application we are working on. So if we are having a business analytics based on the logs, or if we are having any analytics or any logging feature or any map reduce thing, then we would not go for SQL. That is provided better over here in the noSQL. So does it helps?
MongoDB support the foreign key or not? Foreign key.
It supports the foreign key, but the concept of foreign key was the same. Means it was to reduce the data. It was to have the redundancy thing out of the picture. So it was for the normalization thing. But over here we don't need to worry about it. We can have linked documents over here. We can have embedded documents over here. So we don't need to worry about it. we can have foreign keys, we can make our own queries, we can type queries after queries, and we can use projections and thereafter. So we understand the CRUD. So over here, I have some. So first we install Mongo, that's basic. We will install Mongo on the system, and then we go to the terminal and hit Mongo. And it means MongoDB gives us three kernels, three daemons. One is Mongo for running the bash, the shell of the Mongo. One is MongoD to have replicas and all. One is MongoS to have Mongo shardings and all. So we are using simple bash over here, simple shell over here. This is Mongo shell, and it would have everything like Java, everything like JavaScript. We will have where I equal to 1 and say I. So it will print the value of I. Is it visible?
Click on top of the cell properties.
Which one?
Close that. And cell properties.
From the menu.
Terminal.
I edit from
View.
So, like here you can see, you can use the variable I is equal to 1, and you can just print I as a simple JavaScript. So, we were discussing CRUD. We were discussing the So it is just an example of employees structure in any organization. So
okay, tap control tab. Okay, then.
So we'll have db.s, and this is a string. This is embedded documents. You can see contact as extension in this. This is integer, and this is an array. But in SQL, you don't have array as in data type, or you don't have embedded documents as a data type. You just need to have the string. You can convert JSON into string, and then you can keep your data. So that would not make it much helpful for finding it while querying it. So in this, it would just do this, and it inserts a document into employees collection. So now if you see, earlier when we saw there was no collection, but now if we see there is a collection name as employees. Is it visible? So, and if we see, we can find means what the collection contains. It contains a document which is this. So it is a prettier version of it, and
the ID field you can see is a unique ID.
And there's a unique ID. This ID
Can we create unique ID from myself?
No. You can have another column, but it will by default create an underscore ID. You tell you why. What is this ID?
This ID is basically the first 4 bits, first 4 byte of it is the timestamp, the UTC epoch timestamp, and the next 3 is the machine identifier, on which machine you are working on, and the next 2 are is the unique ID of the database. It's a unique process ID.
आप ओके कर दो, फॉरवर्ड कर दीजिए, कैंसिल मत करिए।
अच्छा,
कंट्रोल टैब भी है।
सर फोर्स क्लिक करते हैं यहाँ पे राइट क्लिक करके साइड अच्छा वही
tab.
You can then forward pop-up that comes.
The Unix epoch timestamp for this means how this string is made. That's I'm explaining. This 4 byte will have the Unix timestamp. Rest 3 will have the machine identifier, and 2 will have the process ID when this was fired, and the random. Then this 3 will have the random string of the while this was happening, and so what Mongo provides us is DB means insert one specific document, insert many documents, and bulk write. So what's the difference is, if so we know this can directly handle JSON and can write into the collection. So we can have direct. We don't need to write a wrapper functions, wrapper classes or wrapper functions in JavaScript to write the data. We can have directly front end hitting the Mongo server to write the data into it. We can just have a wrapper on the server end which handles the routing request and puts the data into the server. So this insert is so we can handle it by having insert 1. Means if we expect only one document to be written into the collection, we can use this string to give the middle name into the other document. It doesn't have the middle name, but still it will work. Means that's the schemaless thing.
So we can insert duplicate data here.
Yeah, because it's generating its own ID, its own unique ID. So whatever data you insert, it will be duplicate. It won't make much difference. But you can group it, you can remove it after it if you want. And this is example of insert 1. So insert 1 would insert and return the object ID of it. So the syntax of insert is insert DP collection, insert the collection name and the document thing, whatever key value pairs you need to give in the document, and it will store it. Move on to read. So in read we have few predefined functions. We can create our own functions also, and first of all the basic function is find, and this takes the query as a JSON. You can see this is collection, this is query criteria, whatever query we want to make, whatever field we want to have, and this will return a cursor. Cursor is an object in JavaScript and it will return a cursor, and on that cursor you can have other cursor functions like sort, limit, or if you want to change it into an array, means 2 array function and many other functions. So This is fine. This would return one collection, and you don't need to have limit over it. You can just have one collection, one document returned. This would return the count of it on, and on this cursor you can also have this count function after it, and this would return the count of all the documents that were found. Aggregate is for grouping the things in SQL, and if you want to run a distinct or group any other kind of JavaScript, any other kind of SQL, you can use it in this format. Means it provides you the basic db.run. These are all the wrapper functions, and you can have like this format to search in the database. So we have many predefined qualifiers for it. It's like $equal means the syntax is field, then whatever qualifier we want, and the value. So just an example. So over here you can see the document contains first name, last name, designation, way in which they are sitting, or contact, which is an embedded document, which have extension or mobile, experience, and skills. So if you want to search the people who are sitting in senior way, we would write db.collection name, and in this it would be a JSON which would have way as senior. So this would return this. This would return two documents. One is Yamni, other is Amit. Similarly, if you just need to find the count of it, you can use like this. It will return 2. So there are many other like equal to, greater than equal to. Means what it does is it matches the value by the name db.collection.update. And so there is db.collection.update1. It will only update the first document which gets found in the query, and update many for multiple updates, like update all we have in SQL. And this means in SQL we can use it in different way. And over here we can replace the whole document, like example. Like if we need to change the extension of all the people who were sitting in senior bay, so we'll have db.employees.
So it is changing the extension of all those serial.
So for this one, it would be changing only for one because it was simple update. And if you write update many, it will change
For all.
for all. Means there were two matched and one of them is updated. Over here it was one matched and one was modified. Okay. And what this provides us is not only update it, we can also upsert it. Upsert is either update it if the document is found or insert it if it's not found. So, any questions? Okay. So we can upsert the document in MongoDB. And thereafter we have the final thing is delete. So we can remove, means we can delete any document by giving just the query, means removal criteria, and into this. And if we want to delete one document, we need to make sure we give and delete one. If we want to delete many, we can give and delete many. Or if we want to drop the whole collection, we can use db.drop, collection.drop, and it will drop all the whole collection. And if we want to, means I'll show you this one example. So it will delete one and it will delete all the three of them. And similar as for db.drop. Return true, and now if we see the collection, it doesn't exist. And the last thing is the indexes. Over here we have single field index, which is by default it's _ID, the Mongo ID, and we have compound indexes. We can give indexes on multiple keys, and we have multi-key indexes. So multi-key indexes is for the embedded documents. Like we were having this contact.mobile. If you want to index on mobile, we can give just the multi-key contact.mobile, and it will index that field also for the collection. And
Can we also have composite key?
Yeah.
pardon? Can we have
Composite keys.
Composite fields. You can have two fields.
Is that for compound?
pardon?
A compound field, no?
Yeah,
is a
compound
field.
fields. We can have
Two
multiple fields, and we can index it, and we can index it ascendingly or descendingly. So it would just need one or -1 for ascending and descending respectively. Questions? So while choosing noSQL, we need to keep only two things in mind. One is there's always the system will always be available, and the second thing is that we should always choose it when we have large number of data and we do not need to worry about the redundancy. We can have any amount of data and we can have any amount of data and we can make sure that it is always available. So that's it for today. Thank you.
Any questions?
Yes, sir.
Let's say I have a site and I am already using MySQL. So my requirement is now starting the MongoDB.
Yeah.
So what will the steps to create to schema?
Yeah. So there are many tools which you can use to convert your data, your MySQL data to the MongoDB data. So first of all is you can structure the the SQL data into one document, means how one single document will look, means all the joins, and then you can start pushing it to the Mongo thing. Or you can write your own script. So what that script will do, it will
MySQL data already very complex.
Yeah.
So it will be great if we have the schema to create like any procedure.
So first you need to denormalize all your schema, and then you need to means traverse it and push it one by one into your Mongo. Or you can have bulk insert, the bash thing, which you can means insert 1000 documents or more in one go. So is it?
It takes some time. It's not, there's no
It's
automated.
not easy, right?
It is easy. You don't need to worry about the schema part. You just need to have one collective document. One means a document which comprises of all the knowledge of that specific entity. You need to make that thing. You don't need
But
to worry
MySQL
about the
have
schema.
different keys, lot of.
So it's very simple. You just need to have a script which will create a JSON or an XML structure for that entity with all its values, all its embedded documents. Means if let's consider.
Thank you.
Thank you. Very nice tech talk.